So today our learning intention, we will learn about something completely new for you. We will learn about modulus, function and modulus itself. We will learn today about modulus. Modulus. It's something that I'm saying completely new. Definition of the modulus function. It's a piecewise or hybrid function. F of x equal x for x greater or equal 0, negative x for x less than 0. So if we will sketch the graph of this function, we have for positive values of x, it is exactly as y equals x. For negative, it's exactly as y equal negative x. Y equal negative x, y equals x. So modulus is always positive. This is a graph of the modulus function. This is a definition of what is modulus. So if you take modulus denoted, probably need to write this f of x equals, notation is two vertical line, that modulus equals that. So if you take, for example, modulus of positive number, for example, modulus of 3, it's exactly equal 3. But if you take modulus of the negative number, modulus of negative 5 is positive 5. To better understand, modulus effectively is a distance. It's a distance. So when we say what the modulus of negative 5, we're asking what is the distance of that point on the number line. We have number line 0, we have negative 5. So this is what is the distance from this point to the origin. And distance is 5. Distance cannot be negative. Distance always positive. Makes sense what modulus is? Yeah. Now, solving equations with the modulus. Let's start from very simple equation. Modulus of x minus 3 equals 2. Modulus x minus 3 equals 2. The easiest way to solve this, understanding that modulus is the distance. So we draw number line, and we have point 2. We have point 3, we have point 3, and we're looking for points which are at what distance from 3? 2 from 3. So which point? So that will be 5 and will be 1. So solutions will be x equals 1 or x equals 5. So this question asks which numbers are 2 away from 3. Make sense? Yes?
Is there a difference if it's x plus 3?
If it's x plus 3, then we will be looking distance from the negative 3.
Okay. Yeah.
How? Yes?
Can you just do plus minus 2 and then add 3?
Now I'll show you what you're talking, how to solve this algebraic. This will solve just from the understanding the modulus is a distance, just sort of graphical way. But now, what we need to do, we need to consider two cases, because this makes expression in the modulus always positive. So we need to consider two cases, x minus 3 greater or equal 0, or x minus 3 less than 0. We need to consider these two cases separately. Why? 2. I'm thinking about the next question. X minus 3, when we have x minus 3 greater or equal 0. In this case, for those, this could be just drop modulus. We have x minus 3 equals 2, because the number inside is positive. Modulus doesn't change anything. But here, when we have negative, what modulus does with negative? Change, make it to same but positive. So that will become negative x minus 3 equals 2. Does that make sense? Modulus is, again, when we have modulus of x equals x, when x greater or equal 0, or it's equal minus x when x less than 0. What is inside the modulus? We have inside the modulus sign, we have x minus 3. When it's greater or equal 0, you see, we just drop modulus sign. It's same x, same thing that is inside the modulus. So we have x minus 3, we drop this, we have x minus 3 equals 2. But when the expression inside the modulus is negative, we need to switch sign to opposite. Because we won't make it positive. If x minus 3 negative, I will make it positive, with the same way we put minus at the front. So from here x equals 2, x equals 2 plus 3 equals 5. From here we have 3 minus x equals 2, x equals 1, we get the same. Why it's 2? Because we're solving this equation. I've showed you how to solve it with the number line. Now I'm solving how to solve it, as Joseph mentioned, algebraic. Make sense? Now, solving more difficult question. If we need to solve, let's say, 2x minus 5 equals 3. 2x minus 5 equals 3. So again, there are a few different ways to approach. Pure algebraical way, how we just did. So when 2x minus 5, so expression inside the modulus is non-negative, positive 0. We can just drop modulus. We have 2x minus 5 equals 3, 2x equals 8, x equals 4. If we have the expression 2x minus 5 is negative, what we should do, what we should write? We put negative at the front, negative 2x minus 5 equal 3. So we have negative 2x plus 5 equals 3, 2x, 2x equals 1, sorry, 2x equals 2, and x equals 1. Make sense? This is a pure algebraical way to solve it. Make sense? Now, if we will have, we can solve its a problem that will be the good way to solve. Now, more complex equation. If we have 3x minus 1 modulus equal 5x plus 2. Equal 5x plus 2. Okay. Now, before doing that, make step aside how we graph the function f of x equal modulus 3x minus 1. So, how we graph in general, how we sketching the graph of modulus f of x when you take modulus of the function. We start from sketching the graph like there is no modulus, like 3x minus 1, which will be obviously a straight line with the y-intercept negative 1, x-intercept 1/3, and it's a straight line. This is 3x minus 1. What modulus sign does? It removes the negativity. It makes everything positive. So this will not exist anymore because modulus cannot be positive. We do reflection in x-axis. We do reflection in x-axis. So modulus will be has to be the same values. So when this is when we sketching the graph modulus of the function, we just reflect everything that below x-axis, we reflect in the x-axis. Because modulus makes negative positive. When it's negative one, but with the modulus it becomes positive one, and so on. Make sense? Does it make sense? Yeah. Okay, now let's apply this to this equation. Let's sketch both graphs. Let's sketch both graphs on the same coordinate axis. One graph is modulus of 3x minus 1, which we already know. 1/3, 1. This is modulus 3x minus 1. Now, what will be the modulus of 5x plus 2?
Can you tell me that? She's so loud.
So, sketching graph modulus 5x plus 2. We start again from the graph 5x plus 2. So we have 2, and we have the x-intercept negative 2/5. And we will have this will be reflected. The only one probably I did wrong thing. I made the same gradient, which is not good. This graph has a steeper gradient. Probably because this one should be probably a little bit more here. And so from the graphing, no, they're not parallel.
On the left side.
I care about the right. Now, we have this gradient. No, actually we can. This one will be steeper. So we have 2 points of intersection. Why we did it? What it tells us?
Which line are we looking at?
Where we know we're looking on both lines. This is 5x plus 2 modulus. But where we have, will we have any positive solutions?
Yes, one.
No.
Positive solutions, no. They don't intersect for positive x. They don't intersect for positive x. They intersect only for negatives, but another important thing. We have, which branch is this? Positive, and this is negative. So how we can find this point? Negative branch of this is negative 5x plus 2.
No, but that one's positive. It's not.
Yeah, it is.
Yeah, it's a positive.
Sorry, this is negative.
No, it's
Negative.
not.
This one, 5x plus 2, yes, 5x plus 2. This branch is positive, so we don't change the sign. But this branch was reflected. So this branch was reflected. So we change the sign equal negative 3x minus 1. And we solve it. We have 5x plus 2 equal negative 3x plus 1, which makes it 8x. 8x equals negative 1, x equal negative 1/8.
Yes.
Yeah.
No.
5x plus 3x equals 8x, 1 minus 2 equals
Yes, you're
minus 1, minus 1 divided by
My question is, Mr. B,
Yeah.
would we always have to draw a graph, or is there like an algebraic way to
8. There is algebraic way, but sketching the graph
Yeah.
is, I'll do algebraic way. Sketching the graph tells you much narrower work. It will be much more working when if you do it algebraic.
Okay.
This is more simple way.
Okay.
It gives you very good hint. Now, this point is when both branches are reflected. Both branches. So we need to solve now negative 5x plus 2. equal negative 3x minus 1. That's why we did this graphing. So instead of solving many equations, we just narrowed it only to this. So we have minus 5x
Find all the negative.
minus 2 equals, or we can drop negative. We can drop negative, so we have 5x plus 2 equals 3x minus 1. We have 2x equals negative 3. And we have x equals negative 3. So we have two solutions.
But how
X
can I always get this wrong?
Huh? Why are we getting wrong? We probably forgot basic arithmetic.
But you got it wrong?
No,
Arithmetic. It's not algebra. It's arithmetic. It's primary school.
Joseph, you have to toughen up your math skills today.
Make sense?
Yeah.
Because if we will do it algebraically, then we will have to break it into quite a few different equations. We need to consider when 3x minus 1 greater or equal 0. So x greater or equal 1/3. When x greater or equal 1/3, we have this will be, we can just drop modulus here. This will be positive as well when x greater. So we drop both moduluses, we have 3x minus 1 equal 5x plus 2. We get 2x equals minus 3, x equal negative 3 on 2. But we're looking for solution in the interval x greater than 1/3. We get solution, but is it in this interval? We reject it. We reject it because it's not in the given interval. We'll get this solution again, but we have to reject it now. Why we have rejected? We got negative 3 on 2, but we get this equation when x greater or equal 1/3 only, because then both expressions are positive. Now, we consider this equal, we have 5x plus 2, consider that equals 0, so x equal negative 2x. So we need now consider the interval, and this will be, and this is equal to 0, 1/3. So we need to consider another interval from negative 2/5 less or equal x less or equal 1/3. Why consider this interval? What will be the sign of this? Between 1/3, negative 2/5 and 1/3. What will be the sign of this?
Negative. Positive.
Negative. When x is in this, when x less than 1/3, this expression negative.
Oh yeah, that one. Yeah.
Of this expression,
Positive.
positive.
Yeah.
So we put minus only for this one when we remove modulus. We have minus 3x minus 1 equal this positive, so 5x plus 2. We get minus 3x plus 1 equal 5x plus 2. We get 8x. We get 8x equal negative 1. X equals negative 1/8. Is this in the given interval? Yes. So this is the solution. And now we need to consider the third interval when they both will be negative. When they both will be negative. So we consider now when we have x less than negative 2/5. Now they both negative. So we need to solve minus 3x minus 1. Negative 3x minus 1 equal negative 5x plus 2. And we get the solution that we had before, x equal negative 3 on 2, which now is in the interval. So yes, we got the second solution. So you see, when we do purely algebraically, it's much more complicated. If you do first graphs, then you it's easy. It's narrow your working. Now, so how we again apply this modulus of the function. For example, if you want to sketch the graph f of x equal modulus of x squared minus x minus 12. We start from the sketching graph what is in the bracket. So we start from sketching the graph y equal x squared minus x minus 12, which is obviously is parabola. And you're not interested in the turning point at this stage. Actually, we can find it. So we have what the x we have in x-intercept are negative 3 and 4, yes, negative 3 and 4, and we have parabola. Now y-intercept negative 12, and what will be the turning point? X-coordinate of the turning point. Minus 3 plus 4 divided by 2 is 1/2. X turning point is 1/2, and y turning point is we have 1/4 minus 1/2 minus 12 will be 12 and 1/4 will be 40, negative 49 on 4. Negative 49 on 4. So we have this is our turning point. And then we sketch graph of x squared minus x minus 12. What modulus will do with it? It will flip, but only negative part. So it will be, this will be 12. So that will be the graph of the modulus of this. So we sketch the graph of the original, and what is below x-axis, we just flip around the x-axis. Yes.
You drew like a smooth curve, isn't it? Like a.
Yes. It will not be smooth. You're right. It will not be smooth.
The book shows smooth.
Good job. It's not differentiable at negative 3 or 4.
Yes. It's not differentiable at a point.
It's tangent isn't smooth.
Yeah, thank you. Very good observation. It's not smooth points. Makes sense what we did?
Yeah.
Now the last thing, if we have to sketch the graph when we have modulus of only x. So when we need to sketch the graph of, when we have modulus here only. So we sketch in graph f of modulus x. We sketch in graph f of modulus x. Not modulus of the function, but function of the modulus. Any ideas how the graph will look like?
Modulus squared, isn't it just x squared?
It will be just x squared. It's equal, yes.
It's the same, nothing changed.
What? You are, bro.
Any ideas?
Oh! The one thing you cancel the name
And for all negative values for x, because instead of negative values of x, we will have now positive value of x. So what will happen, this branch gone. The all negative branch for negative x is gone. Because x always positive. And what we do, we leave only this branch, but then we reflect it in why we repeat it for negatives. So that will be now negative 4.
The what? Doesn't the left just not exist?
It exists, you can take negative 4, substitute negative 4 here.
Ah, okay.
Substitute negative 4.
Why negative 4?
I get it.
Because this is reflected, this branch for positive x is just reflected in y-axis. So if you have this was 4, when you reflect it becomes
But I
negative.
thought modulus makes it so it can't be.
But we're not taking models of the function. We're taking only x. So we replacing for all negative x, we replace them with the positive x. So we should get the exactly same values of y as we had for positive x. Make sense? So if it's modulus of the function, we reflect part below x-axis, reflecting the y-axis. If it's modulus of x, we remove the left-hand side
So it's like an ostrich.
and make this part reflection of the graph for positive x values. Make sense? Like, subscribe and donate to help fight all terrorist countries and organizations, Russia, Hamas, Iran, etc. Support Ukraine and Israel.